Our easiest derivative. Drum roll. The derivative of e to the x is e to the x.
What are these notes called?
Let's call them 5.4. Here again, you're going to have 2 different pages. Okay. This is not what's taking 20 minutes. We're going to do some examples. Okay. I do want to remind you that the natural log and e to a power are inverses of each other. So when you have e inside of a natural log, they will undo each other. Or when you have a natural log and the exponent of e, they will undo each other. Do you remember that? Okay. I just want you to be aware that those are inverses and that they will undo each other. We won't need that a lot, but sometimes you will see problems written with those properties where you need to be able to understand that they cancel each other out and you have a much simpler problem. Okay. Okay. So the derivative of e to the x is e to the x. What I'd also like you to, just to save time, I'm not going to go through the proof of why that is. What I'd also like you to understand is that if we have a function inside of our power, we're still going to apply the chain rule. So I like to call this rule copy-paste. The derivative of e to the x is copy-paste e to the x, right? So the derivative of e to the f of x is copy-paste e to the f of x, but then we have to apply the chain rule, the derivative of what's inside. Okay, but copy-paste. So we'll go through some examples, and then we will talk about the derivative of a to the x when our base is 9. All right? Thank you for appreciating it. Here are our first 2 examples. Did you miss it?
Yes. Got it, yeah. I was like, e to the 2x, e to like.
All right, so y equals e to the 2x. Y equals e to the 2x. When we take the derivative of e to a power, we copy-paste and then multiply by the derivative of the inside, which would be 2. So make it look pretty. We have 2e to the 2x. Done. Okay. Second example, y equals e to the 2 over x. Y equals e to the 2 over x. Well, our derivative, if we have e to a power, we copy paste, but then we need to apply the chain rule. Now, if we're going to take the derivative of the inside, which is 2 over x, what would be a nice way to think about that? 2x to the negative 1. And if that's the case, then we can apply the power rule. Drop the power of negative 1, decrease the exponent by 1. Okay, so you can rewrite that to look pretty. You can leave it like that. I really don't care. Do you have a question? You're just thinking thoughtfully. Okay. All right. What do we have here? We have a product. Please, at your pod. No, you just have e to the x squared.
Oh.
You have e to the x squared. Okay? Take a moment at your pod and find this product rule for me. Okay, let's try our product rule. Chris, what's the derivative of the first function? 1. So we have 1 times our second function, e to the x squared, plus our first function times the derivative of our second. Jovano, what's the derivative of the second function? E to the x squared? E to the x squared times 2x. She had a little inflection like a question mark. McKenna R, do you agree? You agree? Okay. Jovna, you have at least one stamp of approval. Okay. I'll stamp it, all right. That's right. Whether you rewrite it or not, there you go. There's our product rule. Okay. All right, one more before we do a new rule. What? We have a few rules to remember, yes. Well, if I don't know that it's the power, I might think that it's not the power. Because we have power, and we're multiplying by something with all right. So our derivative of e to the 2x squared plus x minus 1. We need to copy paste. Multiply by what? Which is what, Mandy? Yes, what is the derivative of that? Okay. If I wrote it like this, would I be happy with that? No, because it's a quantity. I need it all to be multiplied. Okay? You can write it out in front of the e to the power. You can write it behind. I don't care. Just make sure it's in parentheses so I know it's all being multiplied together. Okay? All right. Okay, don't write this down. Don't write this down. But do you agree with this statement up here? Okay, because technically this is e to the natural log of a to the x. When we're multiplying, because you can put that out in front. When we're multiplying, we can bring that in as a power. And e to the natural log, what did I tell you that it does? It cancels each other out, okay? Now, I'm just showing you where our derivative comes from, okay? Don't write anything down yet. So instead of writing a to the x, I wrote it like this because I know how to take this derivative. The derivative of this is copy paste times the derivative of the inside. Well, the inside is the natural log of a times x. Okay, natural log of a, that's just a constant. So that's natural log of a. Okay, those two cancel out. So our derivative for a to the x is natural log of a to the x. Write that down, highlight it, whatever you do with your important rules. Okay? Very similar to what we had with logarithms, where it was the same as base e, but we have to multiply by the natural log of the base. Okay? So it's still going to be copy-paste, a to the x, but we need to multiply by the natural log of the base. If it's base e, we don't have to worry about that. The natural log of e is 1. If it's not base e, we have to throw that on. Now, Nathan, we can do this problem. Okay? You ready for an example? You guys are so enthusiastic. All right. Here are the two we're going to do for now. 3 to the x and 3 to the 3x. Okay. If y equals 3 to the x, then our derivative is going to be copy-paste times the natural log of the base. What's the difference in our second example? Okay, that 3x is our exponent. Okay, so we're going to have to apply the chain rule, right? So we have y prime is copy paste natural log of the base times chain rule, the derivative of the inside is 3. Now the book may rewrite this as 3 to the 3x plus 1 because we have the same base, we can add the powers. I would not expect you to do that. I would expect you to just leave it like this. I'm fine with that. Okay. Right, this is 3 to the 3x, this is 3 to the first, so they could write this as 3 to the 3x plus 1, but I don't need that. I don't need that. Okay. Now, let's talk about the difference. Out of these three, which are the ones applied to what we've talked about today? The first two. If I were to find the derivative here, what would I use? The power rule. This is x raised to a power. That is a number. E is a number, right? Okay. Now, I usually don't give you things like this, okay? It's usually like x squared or x to the 5th or whatever. But I need you to understand the difference between up here and down here, where we have a number raised to a variable power versus a variable raised to a number power. Okay, this is power. Okay, now to really throw you for a loop, I could give you something like this, okay, where we have a power that is a variable and a base that is a variable, okay? We're not going to go through this one, but you would have to use logarithmic differentiation to figure that one out. You can't use any of the rules from up here because we have a variable in both places. You would have to use logarithmic differentiation. Just for you, buddy. Just for you. Okay. All right. Last two examples, I want you to do them. Whoop, right there. Come up with these two answers at your pod, and then we'll go over that blue sheet. Check with your neighbor, make sure they have the same thing. All right. Krista, what do you have for this first one? Times what?
8 to sine x times cosine x.
Grace W, do you agree?
Yes.
Awesome. The derivative of 5 to the 3x. The derivative of 5 to the 3x. Lauren, what did you get?
The natural log of 5 times 5 to the 3x times 3.
Autumn, do you agree? Beautiful. Okay. All right, so your homework is coming from two different pages again. The second page is the same as last night. That 362. Okay, that had logs of different bases and exponents of different bases. So make sure you get those exponent problems. Okay. And then the first page from 5.4 has the e to the power, e to the power, e to the power. Okay? All right, let me go ahead and stop this here.